Okay, let's start the session now. And so we started to work upon the pre-trained model. So and guys, you know that tomorrow we are going to discuss about the project. So everyone, I hope that tomorrow you are going to show me the complete project, or at least you would have completed them in a some remarkable progress. So yesterday we had started and we had seen how to read an image. Yeah, whenever you will have multiple image, then how you will be reading them. Okay, so I'll not explain that part today. We'll just directly start with the model building part. Okay, let me mount my drive.
Hello, good
Yes,
evening, sir.
good evening.
Sir, actually, because of some reason, I was unable to attend yesterday's lecture. And if possible, can you give me a small recap about yesterday's lecture, if possible?
See, basically, yesterday we had seen, in the convolution neural network, we just tried to work with the MNIST data, which was the handwritten digit image. But what if you have to read the image? So we just discussed the different way we can read the image, and then after we just saw how the multiple image can be read, and we just witnessed the application of the globe function. You will just see the code, and if you stuck anywhere, you just let me know. We'll discuss tomorrow. No issue at all. Okay.
Okay, thank you so much,
Yeah.
sir.
So this my drive is mounted. Okay. We have read this library. Now you see here in this disease underscore path, we have given the path of the folder where are all the images are lying. In the same way, in this healthy underscore path, we have given the path till the folder where all the images are lying. And then after, we use this glob function just to say that, okay, after this, whatever content is there, that will be concatenated. So one by one, in this way, you will be reading the image. Then suppose we had read the images. Okay, hold on. Okay, you see here, after reading the images, what you have done, whenever you will have the the image data, so just to normalize them, what you will do, you'll just split them, you'll just divide them by 255. Okay, after that, let's split into train and test. Okay, let's split them into train and test. Let me explain this. See, basically what is happening in this disease underscore images, if you remember, when you were reading the data, when you were reading the images, then in this you just maintain two lists, one for the images, another for the labels or the output. Okay, so means this image will work as an input and this label will work as an output. But the problem is that you have this disease underscore images which will be containing only the disease images. You will have the healthy underscore images which will be containing the images of only healthy leaves. Yeah, which will be containing the image of the healthy leaves. So that's why what we'll have to do, first of all, we have just splitted our disease images into train and test, and we have splitted our healthy images into train and test. And you see, as an X we are providing the disease images, and as a Y we are providing the disease underscore labels. Here we are providing the as a healthy image as an X and the healthy labels as a Y. So what is the meaning of that? You will have separate X train for the disease, you will have separate X train for the healthy, you will have separate X test for the disease, you will have separate X test for the healthy. But the thing is that whenever you will have to train your model, in that case you will have both classes together. You should have both classes together, and that is why what we are doing, this X underscore train you are getting, where we are concatenating the healthy and disease both. In the X underscore test also, we are concatenating the healthy and disease both. Why? So that you should have the data in which you will be having the healthy and disease both. Yeah. But unfortunately, what has happened in this case, the images were separate, the label was separate. So just to make an ideal data set, what we have done, we just concatenated them. And in the concatenation, what has happened, when you have maintained the label, and the label we had, disease image or healthy image. So just to, you know, uh, train the model, we just converted them into 0 and 1. Yeah. We just converted them into 0 and 1. If the disease image is there, so if the disease label is there, it will be 0. If the healthy label is there, it will be 1. Did you understand this? Why we have done this part? Everybody? If you don't,
Yes, sir.
okay. Then you see, I am not going to, or if you want to see, you can do that. You see here, in this way we have just healthy images and the disease images for the train and test. Now let's talk about the model. Okay, so you see here, guys, that we are using the Inception v3, and this Inception v3 is what? It is the ImageNet model. It is a pre-trained model where the weights are ImageNet. What is the meaning of the weights are ImageNet? Means this inception v3 is already trained on what? On the ImageNet classes. Yeah, ImageNet classes, and you see it is having the 1,000 different classes. Okay. Second thing is that here we'll be taking the input in the shape of 224 by 224 by 3. Okay. And flatten means you are converting them into artificial neural network, fully connected layer. The dropout is equals to 0.5. What is the meaning of this, everyone? What is the meaning of dropout 0.5?
सर कंसाइज कर देना.
No, no, no. See, dropout means, okay, actually, you have only binary classification, no? So I'll just be using sigmoid. Dropout means 0.5 means only after, whenever you'll be updating the weight, only the 50% of the total weight will be updated. Say you have 5 features. You have 5 features. So whenever you'll be trying to, one second. Say you have 5 features, huh? X1, X2, X3, X4, X5. This is connected here. So how many weights are there? W1, W2, W3, W4, W5. You just applied the integration function, you just applied the activation function. And then you have this Y. Because you are using the artificial neural network. How can I say? Because you see, you have applied the flatten, you have come to the fully connected layer, which is your artificial neural network. So after getting the output, what you are going to do, just to improve the accuracy, you're going back and updating the weight. You're going back and updating the weight. But when you have fixed that the dropout is equals to 0.5, it means out of this 5, only 3 weight will be updated. Because only the 50% will be updated and the remaining 50% will not be updated. So this is the meaning of the dropout. Okay, clear that is? So you see here, now you see here, you are just defining the output, you are taking the output layer, you just call the model. Yeah, you just call the model where the input you took and the output you have taken. But you have not defined the architecture. You are directly applying the layer. You're directly applying the layer from the inception layer. Yeah. And if I show you the architecture of the inception v3, you see, this is the architecture of the inception v3 and how many layers they have used. Can you see? First of all, they took the input size 290 by 299 by 299 by 3. Okay, and you see the filter size they took, the window size they took as 3 by 3. And what is the stride value they are taking? 2. Here The window size they are taking 3 by 3, but what is the stride value? They are taking 1. Okay. So in this way, they have the different architecture. You see? Can you see here? So means this architecture is already defined. This architecture is already defined. You don't have to work upon it. You just have to build the model and you have to use it. Okay, you just defined the output, you just took the input, but you have not defined the architecture. Yeah, you are just using those layers that is already been defined. And see, you are not specifying the model directly, you are compiling the model, where the last function you have decided categorical cross entropy, optimizer is atom. Yeah, and this is the augmentation. Augmentation means you're just trying to uh, do the analysis. You just try to find out the pattern by doing different kind of augmentation. Means you'll be rotating your image by 20 degree. You will be you know shifting the range by 20%. You'll be shifting the height of your image by shifting percent. So somewhere, and you're flipping, you're just reversing your images also. So these are the augmentation where you're just trying to you're just trying to see, you're just trying to analyze your image by 360-degree. That's it. And that is called as augmentation. Okay. So these are the things that we have done, but you know that you have not specified any architecture. So whenever you'll be using the pre-trained model, in that case, you will not be specifying the model. You'll directly be compiling the model and you'll be training the model on your data. And this model would have already been trained on the ImageNet classes. But now again, you'll be training them on your model. And you see, this is the summary of the model. And you can see here that you have not specified any this layer that are already been specified, isn't? Can you see? Okay. Now let's train the model. So just to train the model, what we are doing, we will be using the batch size equals to 32. And this is why whatever iteration will be there, it will be just whatever the total number of data is there, it will be divided by 32. Yeah, you see? So steps per epoch is what? It is the iteration. And how many epoch we are going to take? Let's train your model and let's make it as 10. Although it will take some time, but no issue at all. We just want to see how much accuracy we are going to get when the epoch will be 10. Okay, it will take time. I think 5 to 10 minutes it will take. So we'll just wait for it. But yes, let's train this model now on our data. And we don't have any other option other than just for doing wait. Although because of the less images in the test data, you're not going to use the you're not you'll not be taking the much time because already we are at the epoch 4. Ramakant, already I have shared the link, the day before yesterday, if I'm not mistaken. Isn't there? Anyway, you see, the training is done. Ramakant, I have shared the syllabus. Okay, so the training is done, and you see how much accuracy you're getting, 94.97. Now, if you increase the epoch, suppose if I increase the epoch from 10 to 20, what happens? Right now, you are getting 94% accuracy. Once you had increased this epoch from 10 to 20, what will happen? Let's check it out. Okay, everyone. So you see, when we had increased the epoch, it has increased its accuracy. So, just to decide that when to stop or when to, what should be the appropriate number of epoch, whenever you witness that there's not much increasing in the accuracy. Suppose that from 20 to 25 epoch, you're just seeing only the 2 or 0.002% of change in the accuracy. Then you can, yeah, it's up to you whether you use this 25 epoch or the 20 epoch. Then, just like you just saved your model in the pickle in the same way. Here we are saving this model using H5 extension. So whenever you will be saving your deep learning model, here that extension will be H5. Okay, and whatever weights you had taken, that weight will be the last updated weight will be saved in this SDF5. Okay, now let me load this model. Let me load this model in this model variable. Now this whenever you'll be using this H5 H5 model, it means what? It is a kind of you can consider it as a jar file kind of. Means whatever cleansing you had done, whatever normalization you had done, whatever training parameter you had used, each and everything, you don't need to run it again. That is already updated in your H5 model. So directly what you have to do, even not here, even on the any another system also, you just have to use this file, and you just have to directly do prediction. Yeah, so we are just you just have to load this model, and means whenever if you want to carry, you don't have to carry the entire program. You just carry this H5 model, and this H5 is saved where? In your current working directory. You see, and whenever when you were started to run your program, if you remember, you just made your current working directory as what? Apple underscore data. So when you go into this Apple underscore data, you will find out that H5 model. You see, and this SDF5, that is your weights. Okay, now so now you're doing predictions on your test data, and see again the batch size will be what? It will be 32. Let's do one thing. We'll be predicting the first 15 input. So that's why we just took in the prediction, we are taking the first 15 value predicted by your model. Yeah. So how you're doing that? If the probability of the prediction, if the probability of 1 is more than 0.5, it is Apple black rod. It should be no. And otherwise, it will be Apple healthy. But I think the condition should be different. Condition should be, you know, uh, the just reverse of it. Because probability is more than 0.5. Okay. So here what will be there? It should be Apple underscore healthy. Why I tell you? Because if the problem is that either yes or no, so you know that yes, no will be coming first alphabetically, and then yes will be coming. So in this way, we'll be just doing here Aponesco disease image. Let's see. Now you see, now it is doing the right prediction. And unfortunately, what is coming? Each images are we just first 15 data is what? It is the healthy images. So let's do one thing. Let's take the not first 15 image. Let's take the say after 15. Okay, 16 to 31. Let's say what happens when we'll have this data. You see. So again, unfortunately, we are getting the healthy image only, and its prediction is also correct that these are the healthy. Okay, so this model is doing correct prediction, but guys, you see, we have just used here inception v3. The way we had used the inception v3, you can plot the ROC curve, and you can see that this ROC curve is reaching to what? That is reaching to the ideal curve. And why? Because somewhere the accuracy is near to 100%. If you want to build the confusion matrix, you can build it, but what is my concern? You see, because the accuracy was 99%, but what is my concern is, see, the way we had just worked with the inception v3 plot, in the same way we have for the densenet model. Okay, so the way we had defined the inception v3, in the same way we are just using the densenet model. And out of densenet, what is the model we are using? Densenet 121. So what is this densenet 121? It is the another architecture that people have used during the competition. And this model was also trained on the ImageNet data that was having the 1,000 different classes. Okay, so same thing was done. Everything was same. Only the difference is in the architecture of the model. So let me show you. You see, this is the architecture of the densenet model. And can you see? Initially, in this densenet 121 I'll be talking about, initially, after applying the convolution, the image size got 112. So means the input size was 224. Then they just applied the 7x7 window and having the stride value of 2. Then the image got 56. So you see, these are the architecture of the densenet 121 model. So how these architecture were made, actually, whatever you're seeing the ImageNet models, they were basically the participants who took participation in this competition, and they just defined their own architecture. They just defined their own architecture to train the model on this 1,000 classes. So right now we are just using the densenet 121. So everything is same. Let's do here. So we'll be doing the model summary. Only what is different? So the difference is architecture. So let's again see the performance of a DenseNet 121 on the same data, on the same parameter. What is the accuracy it is giving us? Okay, let me check here. So when we had used the DenseNet at the epoch 20, can you see? It is giving us the 0.8460. Means in comparison to this Inception V3, this model is not working well. Can I say, guys? Yeah. So in this way, you can work upon. In this way, you can work upon. Getting my point, everyone? Okay, so why I told you about this? Because sometime you might be defining the architecture of the convolution neural network, and you will not be getting the appropriate result. And if you'll be working on the common problems, or you'll be working on the general problem, at that time you can just use it. You can just use these pre-trained models, and you can try with it. Okay. I hope I have already shared this code, no? Yeah. Please reply. Okay. So let me do one thing, Somnath. I just find out do I have any code for other models? Let me check. Uh, Give me 1 second. I'm just looking that file. So yeah, I have the model for the ResNet also. Yeah, so I have just shared that file also in the group. Yeah. So this is all about the pre-trained model. Okay. This is all about the pre-trained model that you work with. Any question? Any question, dear? Everyone?
No, sir.
Okay. So, in this way you can try, and even what I'll tell you, even you can combine the models. You can make the hybrid models where in this way, suppose you just build the 2 or 3 models, just then take a list. Just like if you remember, I just applied in case of stacking. In the same way, you can create the stack of these different models into a one variable and use that stacked model to do prediction for your data. Okay, now in your syllabus there is a you know the Keras API. So I'll just give you the brief about the Keras API today, so that you will come to know, and if it will remain, then we'll discuss on Saturday. Because you know that on Friday means tomorrow, what we are going to do? Everyone, we're just going to check about the project. And I'll appreciate if you would have completed it so that I can suggest you a little bit changes, or might be that the session will not be required and we can start working on the another project. Okay, everyone. So we had worked with the recognition of whether the apple leaves are healthy or disease. Now, guys, what you have to do, you just download from Kaggle or anywhere the COVID data set or any image data set where by using these pre-trained models, you have to classify. You just have to classify. Okay. Now, let's talk about this Keras API. And before that, give me 1 second. I hope my screen is not visible. Wha- You know, I'm why asking this, because I have to share something else also, and that is what. Is a notes. Okay, everyone. Basically, what I did, sometime what happens whenever you just go with the model, uh, what are the different hyperparameters that you should consider and all. So I just created that kind of short notes. Let me show you, and I've shared in the group. So, for example, you see, statistic primer, if you remember initially when I was discussing about the Crispedium process, so whatever I had discussed, I just build in written in this way. Yeah. So I think it will be helpful for you. Second thing, I have just shared you one short notes on the machine learning. You see, for example, say that the logistic regression. So not in the detail, but at least it will be giving you some idea about the things. Can you see, guys? For the sake of a revision part. Okay, still if you need any topic in detail, do let me know. I'll just share you. Okay. So I hope you received it in the group. Yeah. Okay. Just go through with it. It is going to help you out to revise the things. Okay. Now, friends, we'll just start this. We'll just start with the Keras API. Okay, Porus, I'll do that. Even Porus, when you will go with the. Okay, I'll do that. Don't worry, I'll do that. Let me note it down. Give me 1 second. Okay, so let's talk about the Keras API. Okay, so let's talk about the Keras API, because you have seen that uh, mainly when we were talking about the when we were talking about the deep learning, the most important library that we had used, it was the Keras. So how to use this Keras functional API for your deep learning, that is really very most important things. And why do we use this Keras API? Because this Keras Python library makes your deep learning or whatever deep learning model you are creating, this model becomes very fast and easy if you'll be using this Keras. Yeah. While whenever you just use this sequential, whenever you just use this sequential API, so this sequential API allows you to create your model that will be doing layer by layer for most of the problems. And the limitation of the sequential model is that it will not allow you to create the model that will share the layer or that will have the multiple inputs or the output. This is the limitation of the sequential, and that's why you can say that just to compensate this problem, just to have the alternate to this problem, we can use Keras API. When you will have the multiple inputs or the multiple outputs or that share the layers. So in another words, I can say that there's not much scope in the sequential model to have flexibility, while in case of Keras, you will find out a lot of flexibility. Okay, so what is our agenda? The agenda is that we have to somewhere know that how we can use this flexible functional API of the Keras whenever we will be specifying our model. Because if you remember, whenever you have to work with the deep learning model, first of all, you have to specify the model, then you have to compile the model, and then you have to train the model. So, and even if you remember, when we were defining the model, specifying the model, we were using the sequential. Okay, and when we had worked on the CNN, when we worked on the ImageNet models of the CNN, we have used this Keras API. We have used this Keras API, but how or in what way we can use this Keras API? This is the agenda of your second last module. Okay, that is the agenda of your second last module. So, so when we'll be covering this module, see, although we had used each and everything, but just to let you know that what is the difference between the sequential and functional API? Okay, first thing. Second thing is that how can you define the multi-layered perceptron, the convolution neural network using this Keras API? Because that was in your syllabus. So we'll see how we can define this multi-layered perceptron or the CNN and what the different layer and how can we specify it. And not only this, how can we define more complex models? Okay, how can we define more complex models using the Keras API? So when I'm saying about this complex model, it means what? It means it will have the shared layer as well as it will have the multiple inputs and output. Okay, everyone, give me 1 second. All right. So, what we will do when it comes to the different models of the Keras, whenever it comes to the different models in the Keras, so we have the, Keras sequential model. We have the, Keras functional model. We have, the standard network model. And yeah, we have the shared layered model. And obviously you will have the multiple input and output models. And out of that, which one will be the best practice to do it? Out of that, which one is the best practice to do it? It is the things. Okay. So let's start. So first, let's talk about the Keras sequential model. So when it comes to this Keras sequential model, you can say that when it comes to this Keras sequential model, then what can I say? Here, the sequential model, basically API, is actually to create a model. So it is actually to create a deep learning model where the sequence, I can say that the instance of sequential class is created. And then your layers will be created and it will be added into it. Okay. For example, if you remember that, we were using, say, from Keras dot models, if you remember, we were using importing the sequential. It means what? It means this keras.models is not having only sequential, it will have multiple models. And out of that, we are using the sequential. Yeah. And if you remember, for multiple layers, you are using for keras dot models, you're using import. I think not models. It was. Hold on. It should be layers, no? So from keras dot layers, you're importing dense. Do you remember, guys? If I show you, you see here, you're using the sequential and you're using the dense. And just to use the sequential and dense, what you have done? You just used from TensorFlow.keras.models import sequential, and from TensorFlow.keras.layers you just import dense. Okay, so here whenever you'll be using this, what will happen? The layers will be defined and it will be passed to the to the sequential model as an array. And if you remember, when I was explaining this, I told you that this is the first your image, the data. Then you will have the in the first hidden layer you will have the input. 150 neurons. In the second hidden layer you will have the 200 neurons. So it means what? They will be coming in the sequence. Okay. But as I told you that mostly we'll be using the sequential model. But what is the limitation of it? That whenever you will have the multiple different input sources, okay, and you just have to produce the multiple output, at that time, this will become, somewhere lagging and it will become somewhere failure. Okay. So sequential model, since we have already implemented, but just wanted to show you that what exactly this model is. So guys, what we will do on Saturday, we'll discuss this Keras API model in detail. We'll discuss them in detail. Yeah, because today I'll just explain one another model, that is the functional API. But what will happen then? Then again, tomorrow we are going to discuss the project. So somewhere we'll have to start from the initial. So let's just stop here and let's meet tomorrow at the same time. So what is the time, everyone? Yeah,
7:30.
Yeah. So at the 7:30 we are going to meet tomorrow, and tomorrow we will discuss about the project. And probably on Saturday we would have covered this Keras API. All right, everyone. So let's just stop here. So thank you, everyone. Thank you so much. Bye-bye. Take care. Good night.